This tutorial is for the lever section of your lab, and you should have the machine that looks like this. Okay. For the first part, it's going to ask you to place some pennies in one side of the cup. And notice that when I do so, the lever becomes unbalanced, okay? This is your output force, and I want you to place 30 pennies in the cup. Some data you have to take is we need to know the output distance for lever 1. So look at your table 1. Output distance is how far away the balance point is from the cup full of pennies. So measure it with your ruler, record how many centimeters it is in table 1. Look at your table 1. You need to know the input distance. How close is the empty cup, which you will add pennies to the central point of the lever. Okay, measure it in centimeters, put that number in table 1. Notice output force is done for you because we're going to be lifting the same number of pennies each time, okay? Now we want to add pennies to this cup until the lever becomes balanced. How many pennies did you have to input in order to balance your lever? That is your lever 1 data, and it ends with you emptying out your cup once it's balanced. So now our lever becomes unbalanced. We want to make 2 more levers, lever 2 and lever 3. So what lever 2 and lever 3 are asking you to do now is to move the output force. Move the cup full of pennies closer to the fulcrum, and you're going to make 2 different levers. One has the cup 15 centimeters away from the fulcrum, so we measure. Our output distance has changed because we've moved this closer to the fulcrum. Does our input distance change? No, it doesn't. That cup has not been touched. So go to your table 1, put your distances. Output is new, 15. Input has not changed from lever 1. Balance your lever by adding pennies. How many pennies does it take now that we've moved the cup that is full of pennies, the one that you're trying to move? That's lever 2. Lever 3, you're going to move this cup again, as close as you can to the fulcrum, okay, without the cup being interfered with, the lever. Measure that distance. Has the input distance changed? No, it has not. Add pennies into here. How many pennies does it take to balance? For levers 4 and 5, go back to your starting point. It's now going to tell you to move your input force cup, which is this one. And it's going to have you move them in the same way you did your output force cup. 15 centimeters for the fulcrum. Go to your table 1. This is lever 4. Now, the input distance cup is 15 centimeters away. The output distant cup is back to the starting position for lever 1, so what was this distance here when it's as far away as can be? How many pennies now does it take the input force to balance it out? Lever 4. Lever 5, get it as close as you can. How far is it? That's your new distance. How many pennies now? Go and calculate the mechanical advantage of all levers using the formula you were given in class.